let's talk about multiplying and dividing rational functions. So this problem, I actually changed it from the one in your notes to one that's a little bit different because it'll help you practice multiplying a little bit better. Anytime you see a multiplying problem, you're going to start the same way we did the last problems by breaking it down into its parts. So if it's multiplying, if you don't have any glue terms, you're going to factor tree it. If you have glue terms, you're going to think GCF and factoring. So in this one, it's all glue terms. So since it's all glue terms, we need to think GCF and factoring. So it looks like this one is going to factor because I have a squared in it. This one is also going to factor, and I'll give you a hint. It actually has a GCF first. So this one you'll check for GCF and then factor it. This top one doesn't have any GCF, we're good. This one has a GCF. So how I want you to start is I want you to try to factor this, simplify it all out, all on your own. So you should end up with something that looks like that. So I want you to pause the video, try this out on your own where you try to factor it as much as you can, and then come back and see how you did. Welcome back. This is what you should have gotten. So the top one factors to x minus 6, x plus 4. We have a GCF on the bottom of that one, so we get GCF of 2, so then we get x minus 6 left. This bottom one has a GCF of 2x, and you can see I took it out right there, so I'm left with x squared plus 3x minus 4. And then I factor that to x plus 4, x minus 1. So if you're not sure where you went wrong, pause the video for just a second, take a look at it so you can figure that out. But we can already see that there are some glue terms that are canceling. So I have these x minus 6's that are canceling, and I have some x minus 1's that are canceling. Sweet! So now I'm left with x plus 4 over 2 times 1. Anytime you don't have anything left, you put a 1 there. That. It's still a multiplying problem though. So let's talk about multiplying rational functions. Let's go back to elementary school again. If you had something like 2/3 times 4/7, a multiplying fractions problem. If you remember in elementary school, you just multiply across. So you'd have 2 times 4 over 3 times 7, which gave you 8 over 21. Well, we're actually going to do the same thing here. We're just going to multiply across. So we have an x plus 4 times 1. So normally we would write it x plus 4 times 1. But we don't really need the 1 there. We'll keep it there just because. And then we have a 2 times a 2 times an x plus 4. We just multiplied straight across. And now we notice, hey, I have another glue term that's going to cancel on top and bottom. Sweet. There's my puppy. So I have a 1 left on top, and then I have a 2 times x. So a 4x left on bottom. And that's our answer. So that's all multiplying is. Multiplying is not bad. You just multiply straight across and then cross things out, simplify just like what we've been doing this whole time. So now let's look at dividing. Dividing has one extra step, and then it's the same thing as multiplying. I call it the leave, flip, change step. And that's because you're going to leave the first fraction, flip the second fraction, and then you'll change the division to multiplication. And now it's a multiplying problem, exactly like what we've been doing the whole time, which is awesome. And you can even do this leave, flip, change step when it's written in, like in example number 11, when it's written weird. So you take the first fraction and you leave it. take the second fraction and you flip it. And then you take this fraction bar, which means division, and you change it to multiplication. So you just have to do that step, and now it's exactly like what we've been doing all along. So let's go through and actually do these. Example number 10 doesn't have any glue terms. So this is a factor tree. So I'm going to factor 10 to 2 and 5. So I've got 2 times 5 times, and then I have d to the 5th. I'm going to have 5 d's. And then I multiply across. So times factor tree 4, 2 times 2 times c, all over. Now we do the bottom, 6 factor trees to 2 times 3 times c times d. Multiply across. So 30 is 2 times 15, which is 3 times 5. So 2 times 3 times 5 times, I got 3 c's and 2 d's. Now we get to do my favorite step. It's just really satisfying to just cancel all this stuff out. I don't know why. So we're just going to start canceling. I have 2's on top. It looks like I have a 5 on top and a 5 on bottom. I have a set of d's that will cancel. I have another set of d's that will cancel. And another set of d's that will cancel. Got a 2 that cancels. And a c that cancels. And I think that's all that cancels. I don't see any other pairs on top and bottom. So now we just combine what's left. So on top it looks like I've got a 2. And then I'm left with 2 d's, so d squared. Over, I've got a 3 and a 3. I'll underline these so you can see them a little better. So 3 times 3 is 9. And then I've got 3 c's, so c cubed. And that's our answer. That's it. So let's try example number 11. This will be our last one for this lesson. And I'm going to have you start by, this one's going to be a factor tree. And this one's going to be GCF. And then multiply across. So simplify all that, multiply it across, and then see what you can cancel. Pause the clip, try that out, come back and see how you did. Welcome back. Let's see how you did. That had a GCF of 4, so I took it out. I multiplied across, combined everything. I have x's that cancel, and I'm actually going to factor tree that 4. I'll erase it. So that 4 is 2 times 2. And then I can cancel 2's. So it looks like I'm left with a 3. Oh, I can cancel 3's too. Look at that. Cool. So now I'm left with a 2x squared minus y squared all over a y times an x minus y. Now, I actually wanted to make sure to do this with you because this actually factors. Here, let's do this. Let's move it up so I have some more room to work. There we go. So this right here is going to factor because it is a difference of squares. Now remember, mathematicians are not very creative with what we name things. We call it like it is. So difference literally means subtraction. That's the word for difference. So it's subtraction of things that are squared. That's what it means. So right here I have subtraction of 2 things that are squared. Anytime you have difference of squares, it's going to factor out just like this. You take the square root of the first one, which is square root of x squared is x, so that put that in the first set. Then you take the square root of the second one, so square root of y squared is y. Put that down there. And then one sign will be a minus and one sign will be a plus. It doesn't really matter which one's first, just one of each. And that's how difference of squares always factors. And now that we factored that, we have glue terms that will cancel. So that's why we needed to do that. So what we're really left with is that. And that's our answer. So that's everything for simplifying, multiplying, and dividing rational functions. You can now do your assignments and your skill checks.